Today I'm completing the rebuild of a Newage 40M gearbox. This one is out of a dumper for Waterway Recovery Group. It's a gearbox I built around 6 years ago in my previous workshop. It's been interesting to see which of the repairs have worked and what's gone wrong with it since. Here's one I dumped on a bench earlier. This is out of another dumper. The big enemy of these gearboxes is water ingress. Because they typically sit in a dumper like this, there's no protection from rainwater or weather, and as soon as rainwater gets in, that's bad. Water typically enters these boxes around the bolts securing the lid, because these use spring washers, and if they're not properly sealed, rainwater will just get into the spring. Or more commonly, the rubber boot will fail. As you can see, this one's split and water runs straight down the gear knob, straight into the box. Looking in this box, this is the input gear, or the primary gear with the primary shaft on the right, and this bit down here is the output shaft. There is a needle roller race between the two of these, and that is the first thing to fail when these boxes get water in. You won't hear the box getting noisy, because dumper engines are by their nature noisy things, but what you'll see, and you can see both of these gears wiggling up and down, and they start moving out of mesh, and then it's just a clockwork orange from there on in. They will continue to self-destruct if that wear is not arrested. Quite obviously on this box, that needle roller bearing has failed. When these boxes are made, here's the input shaft. The needle roller race is pressed into this input shaft here, and runs on this spigot here on the output shaft. This is the most common failure you'll find on these 40M boxes. Incidentally, this little thing here is an oil catcher groove, which transfers oil via a drilling out here to an oil gallery in there. The oil then travels through that oil hole to reach the needle roller inside. If you have a leaky gearbox with poor seals and people put thicker oil in, oh, that'll stop the oil coming out. It simply means that the oil's too thick to make it along there and into there, and speedens the mechanical demise of the box. When the needle roller is badly worn, it wears down the male spigot on the end of the shaft, at which point the shaft is unusable in conjunction with the needle roller. The input shaft is over £200 to buy new. Output shaft is a similar amount of money. All of a sudden you've got a big repair bill. Looking at the end of that shaft, a repair that I've done on a number of these boxes now is to machine a bronze bush that fits closely on this male spigot. Often the spigot will have worn tapered by the time they come apart, at which point it's quite irrecoverable. So machine a bronze bush and lap it in using lapping paste, and then Loctite it onto the shaft. That bronze bush will then spin within this bore on the input shaft, which normally is okay because the needle race in its cage is pressed into there, and that bore is okay. Once reassembled with the all-important replacement bronze bush for the flywheel spigot bearing, this repair has proved successful on a number of 40M boxes that I've rebuilt, some of which have now clocked up 15 years of use and are still running okay with that bronze bush repair. It's saved 500 quid's worth of new shafts. On this particular gearbox, when I had it 6 years ago, this bronze bush, which is an original item by design, had spun within the gearbox casing and had become loose and was losing a load of oil out the outside. Because the gearbox casing had worn oversized and a little bit egg-shaped, I located the original location of the bore, machined this bore out, and have made a custom oversized bronze bush in order to recover the casing. That too has withstood 6 years of use and does not require replacement. So it's another successful repair there. These studs on the side had pulled their threads in the gearbox casing. As original, they're a unified national fine thread, not the best choice in cast iron. They'd torn out. I've drilled and tapped these out to take a metric 12. They've been Loctited in. They've held okay too. Being dumpers and getting exceptionally hard use, they're probably amongst the most abused of on-site machines. The gear knobs, yes, it looks a bit boy racery, but the plastic gear knobs, which is applied as standard, often do not have the clarity of this engraved knob. And as soon as a brick or a piece of stone bounces off the skip of the dumper being loaded with a digger, the knob normally explodes into a million jaggedy pieces of plastic, at which point you're left with a horrible end. I've started machining these aluminium gear knobs out of random offcuts, and they're far more successful than the plastic ones supplied as original equipment parts. So what's gone wrong with the box since I rebuilt it? That's reverse gear, which had become incredibly noisy, and that's second gear, which had also become incredibly noisy. These are the most commonly used gears on these boxes, second and reverse. Third is a direct drive, so there's no real wear, and first gear is only typically used for manoeuvring the machine. Both of these gear trains were worn out, and I've replaced them complete as a complete train, parts supplied by Plant and Engineering Services in Exeter. Here's another modification, which is a manufacturer's original part, but is a retrofit on the older boxes. This is the gear lever safety interlock. When these boxes were new, there was simply the gate between the two gears, and the lever was quite free and happy to flap around between each of these selectors. With the low running diesel engines used in these dumpers, and the possibility of bricks and debris being hit, bouncing off the skip and hitting the gear lever, it was entirely possible for these machines to knock into gear with the operator not sat on them. And many of the diesel engines, such as Peta PH2s with a governor, will make the dumper drive away even with the parking brake on, and they will just drive off on their own in gear on tick over, and the engine will rack open the fuel racks to keep the engine running. These did result in a fatality and a court case, after which the manufacturers came up with this safety interlock that fits on a modified gate and provides a spring bias so that the gear lever is always midway between each of the gates, and therefore makes it a bit more difficult for it to be accidentally knocked into gear. The dipstick. This is a legacy part which dates from a much earlier design of box. It's supplied even now to accept a Whitworth spanner size, and of course most people do not carry Whitworth spanners, and for this particular size there's no close AF or metric equivalent, so what you normally see is that they're all horribly rounded off like this. You can still buy them as replacement parts, and they come with the same Whitworth hexagon size. Well, surely there's a better way than that. I've started making these replacement items with a metric spanner size. Same thread, same dipstick length, more on dipsticks later, but to accept a metric spanner. 24mm is convenient because it also closely equates to 15/16 AF. And I'm making drain plugs for these boxes with the same size, 24mm. On the older gearboxes, you may find the dipstick is longer. Over the life of the gearbox, these dipsticks were shortened successively to increase the oil level in the box as a result of technical modifications. So if you order a new dipstick and it's shorter than the old one, that's not a problem. It just means that your box is going to have more oil in and will have to leak more before it runs out. Back to the input shaft again, and another common failure on these is that this oil seal surface here puts a groove in the shaft, so you can put as many new seals on as you like and it'll just chew the new seal up, and hence you have oil leaking onto your clutch. Once again, same applies with the output shaft, exactly the same woes. I've used shaft repair sleeves which are available from bearing stockists So it's a very, very thin stainless steel sleeve, which is precision ground. It's got a top hat end on there, which you use to tap the shaft sleeve on, and then once it's in position, you tear off the top hat end like a ring pull can, like a drinks can, and you're left with a precision ground, super smooth stainless steel sleeve for the seal to run on. It doesn't affect the seal diameter and saves you having to purchase an expensive new shaft. This is another repair that's lasted since my previous overhaul of this box, and will go straight back in with new seals, and looks like it'll do another turn. When reassembling the top cover onto the box, many people will use a proprietary gasket, silicone gasket compound to seal around the bolt heads to stop the rainwater getting underneath the spring washers. However, if you overdo it, that silicone will force straight through these holes, which are through drilled, make it into the bottom of the box, solidify, and then in time find their way into this oil groove and then block the oil hole, and hey presto, you're back to a bearing failure on the input shaft. What I've taken to doing is using a very thin smear of gasketing compound to supplement the gasket, and I'm using plain washers with fibre washers beneath them, which has proved to keep the water out, and as long as they're done up reasonably tight, the cover does not become loose. The 40M gearbox has been superseded by the later 85M box, which is more circular in appearance. Some of the parts for 40M are becoming difficult to source. This gear here is one of the reverse gear train and is actually an 85M component. The only difference is it's slightly thicker than on the 40M, and therefore is supplied with a different spacer. That spacer was £30. If I'd have known, I would have kept the original spacer and machined it down a bit thinner on the lathe. One for next time. The box, mostly rebuilt. They are pretty simple to work on. There's no synchromesh. You just need a good quality set of circular pliers and some AF spanners, because these boxes are all built using unified national fine threads. See the safety interlock on this box? It was not originally fitted with one, but it returns the lever to the middle position to select any gear. You need to do two actions of pushing it one way and then another way. Many of these gearboxes, particularly ones that have found their use with steam railways and canal restoration trusts, still do not have this modification. It's really not difficult to fit and provides much more positivity for the operator as well. I'm not going to attempt here to cover a complete strip down of the box because they really are quite simple to work on. This video is just to show some of the common challenges and how to overcome them. A final bit is the metal gear lever covers, which used to be really quite expensive and rust away. They're no longer supplied as a metal item, it's now a plastic item. And it's important that this is pulled down tightly over the replacement gear lever boot. That's what makes the seal around the gear lever and retains the watertightness of the box. Hope you found this either enjoyable or useful, or maybe both even. Stand by for another video on your screen soon.